All right, hello again. One more time. Okay. All right. Let me turn off my cell phone. Okay, so share the screen and we're gonna start. I see. So hey, can you hear me?
Yes, yes, I can.
Okay, so okay, you answered. Good. And Honey is not there on the mobile. Probably. Yeah, there you go. Okay, so we're good to go. Let's uh, let's start. Very first thing, I'm going to ask you a question because today we're going to talk about pointers. My question is anybody interested for me to go to talk about pointers from the beginning and explain what they are as if I'm teaching to IPC people and IPC student and then come to OP345, or you want me to just directly start from pointers? So uh, I'm gonna do the poll right now. Yes or no? I just want to see how many people want to. Wow. Okay. All right. So the majority is saying no. Therefore, we are not going to review from the beginning. I'm just going to start the pointer as is. If anybody have any problem with the pointers, then you can actually um, um, contact me, and I'm going to take you through it. Okay. So it's not going to be a very long session, and um, that's it. So uh, talking about pointers, the very first thing that we need to understand about pointers is that they hold address of other variables, and they're very straightforward. We're going to go through it, and I'll explain exactly what is the difference between a pointer and a regular variable, and we'll continue after that. So uh, I can create the best and easiest way to talk about pointers is to give you an example about a pointer with characters. So the very first thing I'm going to do, I'm going to create a character string, and let's put 50 characters over there, and I'm going to set it to say my name over here. And um, a pointer essentially is a variable holding the address of other variables. Therefore, they pointers by themselves have two ways of getting referred to. One is by the address that you by setting the pointer to an address to point to something, and the other is by uh, checking to see where the pointer is referring to. In this character name 50 thingy that I have, we know from the definition of arrays from IPC 144 and OP 244 that name is a pointer pointing to a piece of memory with 50 characters in it, and happens to be far out in there. So if I write over here name, if I actually do a cout name 0, this is essentially the exact same thing as saying as target of name. Okay. So the outcome of the printf of these two things are both f's because they are both pointing to the beginning of the array. Um, Let me make this ready. So we are okay with this. All right, good. So the next thing we need to talk about over here is what happens when uh, pointer values are changed. Pointers are essentially integers. We know that. Um, so if I create, say, uh, an array of 6 integers, if I do say, let me actually start from 1 from 10, it's better because so that we can actually relate to that. So 10, 20, 30, 40. If I say over here, it's the exact same thing. If I say over here, C out, mm, A0, it's the same thing as saying C out target of A. It's the exact same thing like the name. There's no problem with that. But what I want to point to over here is this. If you show the size of the two pointers, so if I say C out, size of name, and compare it to size of, let's put it this way. I'm gonna do something else. So that's not the right thing to do. So now, sorry about that. Now I'm gonna let me bring this up. Now I'm gonna create two pointers over here. One is character pointer, and the other one is gonna be an integer pointer. So integer pointer IP. Okay, and I'm gonna make the character pointer pointing to name, and make the integer pointer point to A. So if I do this, C out target of IP and target of CP. Now what would oh, font a little bigger? Is it better like this? All right, okay. And Vishal, talk to me, because I don't see the chat. Okay, so uh, all right, so let's do it like this. Now, what I'm gonna do, I'm gonna print this out, and but before doing that, I'm gonna ask you a question, and the question will be, so what is the output of this program? What is the output of this program? Exact output. Assume that you're in a test. What is the exact output of this program? I just want to see, like, because most of you said that you don't want to have a review of pointers. I'm kind of testing to see if actually you're good or not. Everybody needs to answer. George, Vishal, Mariam, Alan, Mohammed, Haniye, Yame, Kavan Raj. Question is blocking the screen. Question is blocking the screen so I can see on mobile. Ah, so you have to go off full screen. If you can't see the question, if you can't see the question on mobile, then answer it in the chat. And uh, my dear students, please, when you're joining online, use a computer for heaven's sake. And if you don't have audio, like if you're at school, you can always use your cell phone for audio and use a school computer to see something on a big screen so you can see what's going on. Yeah. So, anyways, so most of you answered correctly, except like yeah. So I'm just gonna publish it so you see what the answers were. Like 10F in any case is fine, and 10 Fardad, I have no idea why is that. Fardad 10 again, I have that's mysterious. Two people actually put that one. So target of IP essentially says IP is pointing to A. Target of IP, it means where IP is pointing to. IP is pointing to the beginning of the array. Therefore, 10 is the beginning. And then CP, target of CP, it's pointing to the beginning of the name. Therefore, it's F. And because of this, the outcome is going to be 10F. So this is something that you need to know clearly. Okay. Now, having said that, if I say size of, if I say C out, size of IP, and I say size of CP, or if I do this, if so either use the microphone or answer it in a chat because you say you cannot see the screen. But I need to know um, if same is going to get printed or different. The good thing is that chat people see, so when you see, you can actually agree or disagree. Two people only, George and Vishal, really?
Same.
All right. Yeah, so it's going to be the same. Why is it going to be the same? Because size of pointers are always the same. It's the target that is different. Now, if I did this, now different is going to get printed. So if I actually run this, you will see that it's going to say different. But if I remove the target out, then they're both pointers. And because they are both pointers, it is going to be the same. Are we all okay with this? Now give me a thumb up or something. I don't know. Somehow respond to me because, yeah. All right. Good. So that's that. All right. So this is essentially what pointers are when we are dealing with when we are talking about pointers. And pointers can point to anything and anywhere, but there's some pointers are kind of different when you're thinking about arrays. If I write over here, if I go over here, see out size of name, then you're gonna be surprised because the size of name over here is not going to be actually 4. So if I print over here size of CP, and size of name. If I print the 2, you will see that size of name is 50. So why is that? And now let's do the same thing for A and IP. So if I do something like this, you will see that the size of IP and CP are 8, but A is 24 and name is 50. Name is why it happens like that. The reason is that the as an array, the name pointer uh, has indicates what is the entire size of what is it being point to. So size of a name of an array in a local place shows what is the size of the target of the array. So if I say size of A, because it's 6 fours is 24, and therefore you see 24. If I say size of name, because it's 50, it's 50. But as soon as I make a pointer pointing to the beginning of the array, then it's always 8. This is one of the mistakes that students make. So if I say over here something like void prn name, and I put over here character uh, const character pointer name, and I say over here cout name, although it looks like it's the same thing, but when you actually call that function, if I say prn name and pass the name to it, obviously it is going to print the name that is for that. But the thing is that if you actually print size of name over there, so I'm going to actually say like this, you will see that instead of 50, it's going to again show 8. So remember, that is one of the mistakes that students make. They think that if they do size of a pointer when an array is passed, it actually shows what is the size. That's not the case. Remember that when you actually call a function, the way a function is called is prn name, and then you have over here const character pointer name being equal to name, which means, so this is main's name. So what happens, it is exactly as if you are setting a pointer to another one. It is not going to carry size, but it's only going to carry the the address of the beginning of the array, and that's what is needed. Are we okay down to this point? If you don't have the poll system in front of you, say yes so I know. So if I don't see 3 people answering, oh, everybody said yes, okay. How come now you saw the poll? But anyways, okay, so that's that. Good. So now we understand this. So let's call this, what am I going to call this? I'm going to call this a pointers and arrays. Now, going through this, let's talk about something else. Let's say I have over here something like I have over here something like, I'm gonna put that integer thingy. Name is fine. Okay, so if I say over here CP3, that essentially means target of third element after CP, which is 0, 1, 1, 23012. So it becomes this. This is fourth element. So 1, 2, 3. It passes three elements and 4 is printed. But how can we actually use this with a pointer? If I have CP over here, how can I have a pointer representation for an array? The answer is that instead of writing something like CP3, you can always, like CP, if I say over here cout, you can always say cout target of CP plus 3. Why do we put CP plus 3? Because like this, you are saying to the address, add 3 characters. Therefore, the number 3 will be added to the CP, and therefore the CP will have that address. So essentially, if I go something like this, if I go cout, uh, uh, reinterpret cast, I think I should do, uh, unsigned address of CP3, and I do the same thing with CP plus 3. And that works the same way with A. It doesn't make any difference. So if I print all these things out, you will see that they're all sitting exactly in the same memory. Okay, so look at these two. You see that? The first two, exactly same. These two, exactly the same. Okay, I think for it not to get truncated, I should say unsigned long. Let me see. Is it going to get truncated again? Yes. What if I say unsigned long long? Just a second. Or size T maybe. Yeah, that's better. Okay, so those are the addresses. Okay, because the um, a pointer is I think 8 bytes, so I have to get outside long long to do that. I think if I do size T, it's going to work too. Let me check size T. Yeah, that's a better thing to write. Instead of writing unsigned long long, I'm going to write size T. Size T. So as you see, the interpretation is the same. But we have to realize one important thing, and that's this one. So I'm going to say over here, in here I wanted to, let me use A for this. No, it's actually okay. I'm going to go cout. In here, I'm going to create a, I'm going to write the exact same, thing, and in here just write CP because I want you to see where it begins. So this is uh, beginning, or let's just I'm just going to separate the two. You know what they are, and I'm going to put the other one over here too. And put a line between the two. So what I want to attract your attention is the pointer arithmetic over here. If you take a look at these values over here, you will see that the address of the beginning of the array is 72. And when I go 3 further, it's 75. And obviously CP plus 3 is 75 too, which means when you add 1 to a character pointer, 1 will be added to it. But when you actually come to an integer pointer, An integer pointer has a different story. If you look at the 52 over here being beginning of the integer, when I go 3 further, it becomes 64, which is essentially 12 bytes later, which is 4 multiplied by 3. So adding a single digit to an integer pointer adds the size of the target, not 1. And that's the only difference between a pointer and uh, an unsigned integer. Are we okay with this? Perfect. All right, so
Excuse me, sir.
go ahead.
Can you like go back a little bit, please?
Can we do what?
Like the one that you told earlier.
I was saying,
The
what I was
difference.
saying,
Yeah.
what I was saying was when you add 1 to a character pointer, and I'm going to do this now. So I'm going to create 3 of them so you can see. So I'm going to have a double, double, D, and double, double pointer, and I'm going to have the address of D in here. Okay, so now if I write something like this, so in here I'm going to say DP, then in here I'm going to write DP plus 1, and CP and CP plus 1, and A plus 1. So when I write something like this and I execute it, this is, oh, I put it in the wrong place. My apologies. Give me a second. Copy. One more time. So when I run this program now, and looking at the output, you will see that when you add 1 to a double pointer, the number 8 is added to it because a double size is 8. When you add 1 to a character, 1 will be added to it because the size of a character is 1. When you add 1 to an integer pointer, 4 will be added to it because the address of the size of an integer is 4. So essentially adding 1 to an address, it means go to the next thing that that address is pointing to. Therefore, if it's an integer, it has to jump 4. If you want to go to the next double, it has to jump 8. If you want to go to the next character, it has to jump to 1. Are we okay with this, Alan?
Thank you.
All right. So that's C pointer arithmetic. All right, that's that one. Next one. Question, did we talk about pointers in this class at all? Did we talk about pointers in this class at all? Okay, so those people are saying yes. Can you explain to me what did I cover? Did we, because there are 2 different classes. Did I talk about pointer to pointers in here? Anybody?
Yes, we had a review from IPC that power
Oh, so we did it at the
the
beginning of the
PowerPoint we had.
semester. Oh, so we did it. Good, good,
Yes.
good, good. So do your class. So it's the other class that I didn't do it. I shouldn't have even asked. Okay, good. So we don't need to go to the pointer to pointers. We know it all, so we are all good fine and dandy. The next thing we need to, yeah, so understanding these type of things, then code like this become more understandable. Like when you're doing string copy, you can simply say while target of destination plus plus is equal target of source plus plus. This while statement is essentially a string copy. Why? Because it says copy the target of source into destination and check the outcome. If the outcome is not null, do the loop one more time. And at that time, one to the will be added to this address, one will be added to this address, and it keeps going like that. Therefore, this loop is a string copy. If I want to do a string length, this is what I can do. I simply go while target of s plus plus, therefore it's going to keep adding to the address of the string until it gets to the end of it, and then it stops right at that moment. My apologies for a second. Hello, can you hear me?
Yes.
Okay,
Yes.
okay, perfect. Sorry about that. Yeah. So as I was saying over here, um, let me just cancel this post. So as I was saying over here, uh, code like this is very common in C programmers. Be careful about this one because if the warning is on, because you have an assignment over here, compiler assumes you're writing a condition and warns you why is it not like this. You intentionally are putting one single assignment because you want the target of destination to be set to the target of source and then the outcome of that examine to be null or not. So this is a very valid C code, but G++ may give you a warning, and you need to be aware of that. Yeah, so that's these type of things are very common in programming using pointers. Are we okay with this code, the one that you're seeing over here? Okay. Anybody wants me like if you don't if you want more explanation, please let me know which part is vague so I can actually cover it.
Um, I don't understand line four, like how that, like where it's like I get what how you're saying it goes to the location and it like compares them and then that's what it runs the while test on.
Oh, you're talking about line number four or eight? Which one?
Yes.
Four.
Uh, four.
Four. Okay, so two things. Keep your mic on so we can go back and forth.
Okay.
Two things you need to consider. You need to keep in mind. First of all, Prost plus is stronger than target of, which means this happens separately. It doesn't. If I wanted the target to be added, I had to put the whole thing in parentheses. Do you know this? Or it's okay.
Yes.
Okay, good. So we know that. So we know when we say plus plus, it's the address is being added, not the target. Now, the thing is that because this is a post plus plus, it happens after the condition is met. Are we okay with this?
Yes.
Okay, so the sequence of things happening are this. First is this happening, which means it puts whatever that is in source into the destination. Now, if source is an empty string, the very first one is null. So it copies the null to the destination, and because the outcome of the whole thing is null, it's false, it stops. Are we okay with this?
Oh, okay.
Okay, now
But
let's say, go ahead.
so like that all individually all the parts make sense. I just don't understand why we put it inside the this while statement rather than having it slightly like in the brackets we normally would,
Yeah,
like the scope we normally would.
because C programmers are geeks. They don't want to like
Okay.
write three more characters. They want to do it quick and fast. And it happens all the time. Like a code, like I hear you loud and clear. You're absolutely right. In this day and age, if you write a code like this, you may get fired, which is perfectly good code. So they would tell you, instead of doing something like this, just check the thing, and then and for example, maybe you want to write destination plus plus and source plus plus over there in two separate statements. I understand that's much more readable, but C programmers do stuff like this all the time, and you need to be aware of this. Among C programmers, this is very normal. It's not cryptic code. But
Okay.
I hear you perfectly. You're absolutely right. It's always better to write this thing. So if normal person wanted to write this, they would have go while target of source. They would do like this. They would go destination will be set to source. That would say destination plus plus source plus plus. I don't know why that thing went like that. And then after everything was done, why is it giving me an error in here? Oh, it's because
Semicolon on
yeah,
8.
semicolon. Okay. And then when it was done, so what happens is that when you reach to source, source is null, and it's not set. Destination will not be null terminated. Therefore it's gonna be uh, destination set to source to make it to make it null terminated. So this series of lines is equivalent to this one. It's exactly translation of what you see up there. You
Okay.
follow? So now,
Yeah.
if you are comfortable with C, I'm asking you frankly, which one you rather write, line number 4 or 5 to 10? You follow what I'm saying?
Yeah, I would always go with the other, the
you want to
5
be
to 10, but yeah, I understand what you're saying.
you would go, but believe me, after 5 years of coding, when you know what's that doing, you don't want to write 10 lines of code. You don't have time. You want to write, just be quick and done with it. So things that, again, you are absolutely right, Aaron. Aaron,
Mm-hmm.
Aaron, correct? Did I say it right?
Aaron.
Okay, you're absolutely right.
Doesn't matter.
I try to pronounce correctly, so my apologies if I don't. Anyway, so you're absolutely right. This writing it like this has no harm, no problem. But since your job will be debugging other people's code, get ready for line number 4. Okay.
Okay.
All right. All right. So
Thank you.
that's that. No problem. So that's that. And yeah, I don't know why I wrote this thing over here before destination yada 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 links. Ah, good. Okay, so this is good. So in here I'm gonna say cd pointer arithmetic. So we don't need to talk about pointer to pointers. So we're gonna go with this one. All right. So we have a very good example in the notes. I'm not gonna sound like a broken record and repeat what we already have uh, on the notes. So I'm just gonna bring that up. So in here I'm gonna go to 345 notes. Take a look at this code. Okay, when you see this code, so in this case, as you see, what I have over here is uh, uh, a class that has a title and it checks for the validity of the title and throws an exception if the validity is not met. A problem with these type of code that throw exception is that the rest of the logic will be down the drain, which means if if the exception is thrown halfway through, your pointer management will be lost. Imagine you have a class, but the class that they have written over here is a little bug because it doesn't have a destructor. But what I'm saying is that if you throw an exception through a class's creation, not even validation, and when you do your allocation, you throw an exception because of something going wrong, you're essentially coming out of the code of the class, and therefore you're going to have a memory leak. So how do I explain this? That the example over here, for it's changed. It's not what it was before. I think I have to write it myself. Um, yeah, let me just write something myself. So what I'm saying is essentially this. Take a look at this. If you have, I'm going to write a very simple code. Explains everything. So if I have over here character pointer name, okay, and or let's say character pointer name like this, and I have character pointer dynamic name. So what I would do over here for whatever reason that I'm writing this function, or yeah, so now in here I get the name, so I go see in name, then I dynamically allocate the name, so I'm going to say dname will be set to name, uh, uh, new character str len of name plus one. It's a code snippet, people. There is no specific logic going in here. Just want to show you the code and see what's going to go wrong. So user enters a name. So in here I'm going to say name. And let's say I want the name to start with F. So what I'm going to do over here, I'm going to do a validation. I'm going to say if uh, if and let's call this one foo. Okay, and in here after doing this, I'm going to say str copy into the dynamic name the name that I received. So essentially the dynamic name will have a matching size for whatever we have over there. And then at the end over here, I want to delete. After I'm done, let's say I'm printing C out the name. And then I delete the name. Okay? Now, through exception handling, if you write a checker over here saying, okay, when somebody is entering a name in here, so I want to copy, then I'm going to say if dname 0 is not equal to f, I'm going to say throw must begin with f. So now it is actually throwing an exception right over here. Okay, so if I try this and catch it in here, I'm going to say C out a name without F or whatever. The name not starting with, or I'm just sorry. I'm just going to say catch const character pointer error. I'm going to say C out error. Silly code, but it just serves what I want to do, and I'm going to explain it. Okay, when you look at and the code looks very silly, but this happens all the time when you have nested functions and your functions do stuff and they throw exceptions. If something goes wrong, for example, if the program runs like this, the program starts with some name that it has. It wants to dynamically put it somewhere and print it. So it gets the name, dynamically allocates it and copies it. Then it checks to see if actually it has an F at the beginning or not. If it does have an F, if it doesn't have an F, it throws an exception and prints the error message and comes out. And because the deletion is happening in the try, an error message will cause a memory leak. For these type of stuff, and this is all in one piece of code. So we could simply say, I could have deleted at the end. Yeah, I understand that. But the problem is that usually when you have function within function within function within function, the functions return or classes create dynamic memory allocation that are deleted in the destructor, and functions do stuff and then they delete information. Sometimes if things like this happen, you need to go into the catch part and delete it. Otherwise you're going to have memory leak. And in many cases, because of this exceptions being thrown and all the memory management logic bypassed because of the exception that is thrown, memory leak is going to happen. That's inevitable. And that's what makes C++ one of the most leaking languages of all time. Because of this exception handling, logics are bypassed and therefore memory leaks happen. Did I get to you by this? Do we understand what I just said? Okay, good. So now because of this fact that we may have memory leak, it would have been nice if pointers could remember to delete themselves when they are not used. We can do that. Remember that we can create wrappers, right? So I can actually wrap things that like we in the test you had a wrapper program that created a dynamic object and deleted it. Dynamic copy of an object and deleted it. We can create something like that. We can actually create a class, some kind of a class. Let's call it, I'm going to call it UPTR. And in this class, I can, let's actually make it a template. So I'm going to create a template, type name T, and I'm going to make this class create a pointer of that type. So let's call it PTR. And I'm going to make it null originally. Okay? Now, the constructor of the class essentially receives an address, and what it does, it simply sets the address of what we had over there to PTR. So what it does essentially wraps a pointer inside a pointer. So when you want to create a pointer, let me just call this main. you simply say UPTR, and I'm going to say I want to create a pointer of type int, and I'm going to say equals to new int. So PTR. So what happens over here? Take a look at this line. This UPTR of mine is a template. So when I say UPTR int, it creates a class called UPTR of type integer pointer. It gets the address that I received, that is an address of a new integer, and keeps it in that property. So we essentially wrapping an address. Do we understand what this wrapper do? So I just want to keep the pointer inside the class and be able to handle it well needed. Okay, so this is good and fine and dandy and nice. So what do I need to do if I want to and what I'm going to do in here is to create a destructor. Essentially, I'm going to simply say, hey, I have a UPTR destructor, and in this destructor of mine, I'm going to say, what am I going to say? I'm going to say delete MPTR. Okay, so now I create, so this is, there's not going to be a leak in this program. If I run the program, as you will see, the program runs, a new integer is created. So now PTR over here will actually point to an address which is somewhere in memory. And as soon as the program ends, it goes to the destructor and deletes it. Therefore, the UPTR of mine looks like a pointer, but it cannot leak because when the lifetime is over, the destructor will take care of it and delete it. Do we understand this? Fantastic. Now that I have created this, I need to be able to make this thing act like a pointer too. When I have a pointer, I need to be able to say target of PTR is equal to 12. Therefore, that dynamic integer will be set to something. Can I do that? Of course. I know how to overload operators. So I'm going to say return a reference of the type, whatever type is. If it's integer, return a reference of an integer. So return of a reference of an integer when the unary operator was invoked, and return the reference of MPTR. As easy as that. So now I can actually say cout. So I can say enter an integer, and then I can say cin into target of PTR. Now I'm going to say cout, you entered PTR, and I'll go to new line. And I don't need to delete anything anymore. So when I run this program, it comes over here and says, give me this. And because it's returning the target of that thing, it's going to actually put it in there. So I can put over here 1, 2, 3, 4, 5, whatever, 4, and I hit enter. And as you see now, PTR has an address of something that is 1, 2, 3, 4, and it's going to print it out. And so it printed it out. You see, 1, 2, 3, 4. And then when the program is over, it goes over there and delete it. Voila. No more need for any deletion. So this pointer of mine is smart enough to know when to delete itself. Are we okay with this? All right. Now that we put this thing is like we kind of understand how it works, I need this thing to be able to work with classes too. I want to be able to have like something like, for example, if I have a structure, if I have struct number, I want to, and in here I would put or say coordinates, and I'm going to put over here int x and y, so I have two things in here. I want to be able to say uh, UPTR coordinate C is equal to new coordinate. Oh, actually, let me just put over here a quick constructor coordinates int x and y. Shoot. And I'm gonna go mx x and my y. Okay, easy breezy. So I create this. Why is it? Yeah, there we go. So in here I'm gonna say 10 and 20. Okay, now that I have done this, I want to be able to say cout c mx and print the x. So I need this thing to work because it's a pointer. It's supposed to do that. Can I do it? Of course. I'm going to overload that. But the difference is that now this needs to be an address, not a reference. So my overload is going to say type pointer operator this, and now I will just return mptr. And now I can actually use it that way. So when I run it, you'll see that it's going to go 10 and 20. So now this is working too. So this looks like it starts working like a pointer for me. Are we okay with this? So the only problem that this pointer will have over here will be the fact that if I set one pointer to another, then we'll be in trouble. If I actually create a UPTR, do I have a default constructor over here? Set to, yeah, we have. So this one I should say set to null PTR. That's that one. And this delete will delete null. That's very fine. Okay, so now I want to be able to have this UPTR and in here integer PTR2, and I want to point to PTR. This is where my pointer will cause trouble. If I do something like this and I say over here cout PTR2, everything looks fine and dandy because they're the same. It's going to be copied to the other one. Therefore, PTR will point to the new integer. But the problem is that when they are going off scope, when the destructor of the first one is called, it's going to wipe out the PTR. And when the second destructor is called, then it's going to cause segmentation fault and program's going to crash at the end. No, what builder? Oh, I put two of them? Yeah. So when I do this, at the end you see it's gonna crash. That is a destructor crash because at the end, well, now we have to wait for it to crash. There you go. Because at the end, uh, the first one's going to delete, and then when the second one deletes, then we're going to be in trouble. Are we okay with this? Do we understand this? All right. Now it's 2:37, and I'm about to talk about some. Oh, George, what's up? You said no. We're not okay with this. Explain. George, you're with me. George, can you hear me? I said, are we okay with
It's in the
this?
chat. In the chat for that.
Oh, in the chat. I can't see the chat. Sorry, let me take a look at chat. Where is the chat? Oh, okay.
Yes, teacher. Sorry, I'm not sure. I'm sorry, I couldn't hear the last part. That's what I meant.
So, what is troubling over here? The
Sorry, come again?
what is troubling here? What is troubling?
Yeah, I'm not sure why no longer is a smart pointer.
Why
Why it
is
no
it?
longer wraps itself up.
You're saying why it crashes at the end? That's the problem. Yeah. So the crashing at the end is because of this. It's the exact same thing that we had. The reason we needed dynamic memory allocation for things. So if this is PTR1 and PTR1, whoa, not this one. If this is PTR and PTR has a pointer in it pointing to something dynamic, pointing to something dynamic, okay? When PTR2 comes to play, the second one gets created, and because they are copied, they're going to point to the same place. And because they are pointing to the same place, when the first one is gone, when the first one actually goes away, it deletes its memory. And when the second one wants to go away, it wants to delete something that is already deleted, and that's when we have crash. Do we understand this?
I think so. I think
Okay.
so, teacher. So basically, it should have, instead of doing a copy, it may be better if it was a move.
Uh, 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 Sadly, I hear the person talking in the background much louder than you. Okay.
Yeah, I'm having trouble with the microphone, but
Okay, that's okay. So
basically, what I'm what I'm saying is that probably should do a move instead of a copy. Correct?
yeah, so we have to implement the copying process stuff to understand how to make these copying work. We have copy constructor, move constructor. We can take care of this, obviously, but how we can take care of it, it's something that we have to discuss, which I wanted to say let's do it after a break. Okay? Everybody's okay to take a break and then come back and continue? Are we okay to
All right,
take
teacher.
people are actually giving me a thumb up, so probably we are. So we are okay with okay. So 10 minutes break and then we'll come back and we're gonna you okay. George, you rose hand. I don't know if it's a thumb up or you're but anyways. So
It's no, no, it's fine, teacher. It's fine. I
okay,
meant to do this.
okay, all right, good. So we'll let's have a 10 minutes break and then we'll come back. Okay, so some of us are not here, but we don't have much time, so I'm going to continue. All right, so now when we are coming to stuff like this, we need to actually make a decision to uh, try and understand what are the circumstances and what we want to do when actually pointers are being assigned to each other. Sometimes you do not want the same phase, the same memory to be pointed by two pointers. You want pointers to uniquely point to something else. If you want to do that, we can enforce that. So let's set this one in a way so it cannot point to two different things and it's going to cause trouble for it. So what I'm going to do, I'm going to add, what I will make sure that this is not going to happen. And this is copy assignment. So what I can simply do is very easily, I can simply say, hey, if you are assigning the pointer to another one, I'm not going to allow it. If you want to copy another one, I'm not going to allow it. So essentially, this is going to prevent cases of copying and assigning as you see over here. So this will cause an error. If you want a pointer to point to another pointer one at a time, what we can do, we can move the addresses from one place to another. So instead of having something like this pointing to a piece of memory at the same time, what we can do is essentially this. We can say, if I want to point to something else, first I have to, if I want to, so this is the one pointer and this is another point, another pointer that we have, and this is the piece of memory that we have, and the first one is pointing to it. Now I can actually adjust it in a way so if I want now the right one to point to that one, I can remove the first and set the second one, and the first one becomes null. So essentially move the data from one pointer to another. These type of pointer uniquely point to a piece of memory. Because of that, they're called unique pointers. So unique pointers work like this. So it's essentially instead of just so whenever I see a pointer is being pointed to another, is being uh, if I want to copy one pointer to another, what I will do is move it to the other one. So I'm gonna call this one so other, and obviously no exception. So what I'm gonna say over here is I'm gonna say mptr will be set to the other pointers mptr, and I'm gonna make the other pointers mptr null. So that prevents the two pointers to be copied from each other. So in here, when I have something like this, all I need to do is to move it. Okay, so instead of doing something like that, I can actually move one to another. So essentially, I can say over here, move that pointer to this one. And now problem is solved. It is impossible for the two to point at the same time to the same variable, and the data will move from one to another, and therefore the other one is going to have a null pointer. Not only that, if one is assigned to another one, I can do the exact same thing. So what I can do is doing with using the move semantics, I can say if operator equal, and in here I'm going to say UPTR other, no exception. Obviously I'm going to say if this is not equal to the address of other, return this. And in here I'm going to say first delete mine. If I am supposed to receive someone else's, first delete mine so I don't have anything. And now then I can say mptr will point to the others mptr and the others mptr. We know. Now, even moving around things will be no problem. So if I have another pointer over here, pointer 3, that is already pointing to something. If I say, let's put something in that int, so I'm going to say new int, something like that. So now if I say over here ptr3 is set to move of ptr2, now I can confidently print the third one. So essentially, it these three pointers um, will make sure that they're not going to have any memory leak anywhere. You can freely allocate any type of memory you want in them, and it prevents any type of leakage and guarantees that the pointer points to one entity, and it's impossible for two pointers to point to the same place. Do we understand this? This is essentially called a smart pointer. So in here, I'm going to call it ABCDE my unique pointer.cpp. Yes, Kian.
So are unique pointers and pointers the same thing,
Yeah,
basically?
unique pointer is a smart pointer.
Okay, got it.
Unique pointer is a smart pointer. And the only difference is that, so you see this UPTR over here? Take a look at this. I'm going to remove this implementation of UPTR of mine. Look at this. Okay. And all I need to do over here is to, first of all, we're going to include memory. Okay. And then in here, I'm going to say UPTR, I'm going to say H, and I'm going to call it unique PTR. Replace all. Okay. So, and do this. All right. And there we go. That's C++'s unique pointer. It works the exact same way that the other pointer worked. So this is exactly the same implementation of the other one. So unique pointers are used like this, and they work perfectly with absolutely no problem. So at any moment when you want to use a regular pointer, and these are objects. So when you create PTR, you treat it as an object. You pass it by reference, you pass it, whatever you are doing with it, you're fine. You can do it. But remember, these are unique, so you cannot copy it. You cannot assign it. If you are assigning, you have to move it. But you can replace any pointer usage that you are doing with this one, and life is beautiful. There's no problem with anything, and it can work perfectly for you. And you don't need to worry about deleting it, any exception handling, anything that happens, because these are objects. When the objects go out of the scope, they're going to remove their own memory, and therefore uh, um, there's no memory leak. So that's unique pointer. So this one I'm going to call EF. That's CPP unique pointer. That's C++'s unique pointer. And the next thing, I'm not going to write the code for you because that's That's kind of crazy, and I explain it why. The other version of pointer that we have is called um, a shared pointer. A shared pointer, I'm just going to draw it for you to see how they work. So shared pointers share the same piece of memory, which means these are all shared pointers, and they have a piece of memory over here, and they all point to it. Okay? Now, what is beautiful about this one is that when you create a shared pointer and you point to a place, what it does, it creates a dynamic it creates a dynamic shared integer between them, and in that dynamics, and they are all pointing to that one too. So for any individual memory they point to, they create a dynamic pointer too. And in that dynamic pointer, they hold the number of instances of the pointer created. This is not a static value. The reason it's not a static value is that if it was static, then it will be shared between all instances. You want these two, you want these two guys, so you want for each pointer uh, a counter to get created, so it cannot be a static. So what happens is that for any address that it's pointing to, it creates a counter. So what happens is this: when the destructor goes out of the scope, it checks the counter. If the counter is 1, then it deletes that one and this one and goes away. If the counter is not 1, it's more than 1, instead of deleting, it reduces the counter by 1. So when this one is getting deleted, it simply changes this value to 3. It becomes 3. And then when the other one gets deleted, it becomes 2. The other one becomes 1. The other deleted, it becomes 1. The other one gets deleted. It sees it's 1. Then it deletes both of them. Therefore, it's gone. Shared pointers, you can have many things pointing to the same place. And the memory that they are pointing to is not going to get deleted until all the objects pointing to the same location are deleted. Do we understand the mechanics or the logic behind this? So I'm going to show you the code all at once. I'm going to quickly walk through it for you to see what it is. Then at home, you go through it and see how it works out. Okay, so let me just clear this. So in here, I have an employee class. Okay, so employee class, forget, that's just for an example and whatever it has. This is my shared pointer. Now take a look at the shared pointer. It not only has a type to a pointer that is supposed to point to, but also it has a counter. I created a private function called wipeout, and wipeout is called to wipe everything up and all the values, uh, delete all the make sure uh, the instance data is uh, is deleted. How? It checks to see if the counter is not the counter is not 0. If it is not 0, it will reduce it by 1. Okay, so if it's 1, it will reduce by 1. If it's 2, it will be 1. So what happens is that first it reduces the counter by 1 if the counter exists. So it checks, is it pointing to anything? Yes, I'll reduce it by 1. Then it checks if after reduction the counter is 0, then it deletes both the counter and the target. If the counter exists and the target of the counter is not 0, it means there are still instances over there. Therefore, the data should not be deleted. That's the purpose of whiteout. So what wipeout does, it makes sure that when it's called, if the counter is not 1, the data is not deleted. And that's the logic behind it. Now, we okay with that? Walk through it later on, but we'll see. Okay, so now the constructor is pretty simple. It sets the pointer to whatever it is, and it sets the uh, pointer to a new uh, variable, to a new size t. And the value of that size t is 0 or 1 based on the pointer being null or not. If the pointer is not null, it means uh, it is some value that is being pointed. So it is actually pointing to something, so it becomes 1. That's the constructor. So the first time it gets constructed, if the pointer that it has over here is uh, null, it's gonna be 0. If it's not, it's gonna set it to 1. For construction, what it does, it first of all points to when it's being copied, it points to exactly what the other one is pointing, but it checks the other one's data. If the other one's data is not null, it adds 1 to the instance. So every time it's being copied, it adds 1 to the copy counter. For the assignment, is different. For the assignment, it says wipe out if there is anything in there. So either it wipes its own data or wipes the data and the dynamic memory if this is the last instance. If it's not, it will just set itself to null, and then it takes over the other, it sets itself to the other data and adds 1 to it. The move and the move assignments and move semantics are identical. There's no problem. If you are moving from one to another, it just assumes the other one, so it moves it. There's no problem with copy construction because it's a brand new one. It just copy constructs the other one, no problem. But if it's an assignment operator, first it wipes everything up, and then it uh, assumes the identity, assumes the values of the other one. And you can actually see how many it has. It has a count. I don't know if the one that the shared pointer of C++ has count or not, but this one, the one that I wrote over here has count, and it has the exact same operator overloads like the other one. I also did a void typecast for it, so if somebody wants the raw address, they can take it out, and the destructor simply wipes out. So the destructor either reduces the number by 1 or deletes everything. And that's how the smart pointer works. Walk through it and take a look at it, and you'll see uh, um, if you have any problem. Come to the lab and I will take you through it and I'll explain everything. That's shared pointer, and so I'm gonna put it over here. This is my shared pointer, and the shared pointer of C++ works the exact same way, but it's C++. So essentially, instead of SPTR, it's shared pointer, but it works the exact same way. Everything works the exact same way. Take a look at it, walk through it, and let me know if you have any problem with it. And that's smart pointers. Any questions before we go? Oh, by the way, one thing I have to tell you, today section B receives its marks and everything, and by tomorrow night you're gonna receive your marks for the midterm, and Wednesday is the time that you are going to, as soon as you get your marks, Wednesday is going to be the time that you're going to book an appointment with me. And if you have any problem with your midterm, if any mark is unfair and it's not set, take a look at it and get an appointment. and be done with it before the drop date. Okay. Any questions? George, go ahead. You have a question, George?
Yes, my question is, are the appointments in person or
No, no, no.
virtual,
It's
or
it's
how
on
do you
Microsoft
request?
Teams. It's on Microsoft Teams. So what you do, please mute yourself. So what you do, uh, you can do two things. Either uh, let me just
Sorry, come again?
please mute. I'm gonna mute you. Okay. So what you do is on Wednesday, either you book an appointment after you see your results of your midterm, and you see the answers and you see if anything's wrong, or you don't book an appointment, just on Wednesday look at my status and just call me without an appointment. If you see my status is not busy, just call me, as easy as that, and we'll talk about your midterm. uh, any other question? George, did I answer the question?
Midterm,
Yeah, go ahead, go ahead. Soheda.
midterm is only 30%, right?
I think so. I don't know. Yeah, look at the addendum. I don't know. Look at the addendum. In the addendum, it tells you exactly what it is. Because every semester it changes.
Because
I gave up. I just do it in a blackboard. Take a look at the addendum. It's there.
okay, great.
All
Thank
right.
you.
Okay. All right, everyone. Have yourself a beautiful day, and we'll talk later.